Hello guys, I hope everybody's able to hear me out. Can I get a quick yes if you're able to hear me out? We'll just start the session in some time, but I hope everybody's doing fine. What's up? What's all? How's everything going on? So after long time, we are back again live with some amazing community sessions like NLP and all. So we'll complete the NLP Advanced NLP series, which had been pending from past many days, right? So I hope everybody's able to hear me out. Yeah. Can I get a quick yes? Yep. Okay, perfect. Hit like if you're new. Please make sure that you subscribe the channel. Press the bell notification icon. Please give me a confirmation once you press the bell notification icon, because this live session will happen from 8 p.m. IST in India. And, I don't want you all to miss any such opportunities of learning with me. Okay. Okay, perfect. So another 1 minute and then we will probably start. Today in this session, we are going to discuss about bidirectional LSTM. Okay. So the NLP, advanced NLP series, we are going to just complete it. Okay. So bidirectional. Okay, perfect. I'm just writing, so hello guys. Hello everyone. I've recently bought iNeuron course. Will it worth it? Yes, obviously it will worth it. Um, the Tech Neuron is available now for lifetime. So please make sure that you realize that particular opportunity and go ahead with it, So it is just going to be for lifetime, any live classes that are going to come up in the further time. Yeah, materials are always available. Now let me just share my screen so that we can start the session. I hope everybody is able to see the screen also, right? So yes, so if you remember guys, what all things we have completed with respect to the previous session? Anybody? Whoever has been attending my previous classes with respect to NLP, right? We completed RNN, we completed LSTM RNN, right? We completed from machine learning like bag of words. Then we also completed TF-IDF. We completed, so Tech Neuron that I purchased is 2-year validity. Mantrajan, just contact the support team, they'll help you out with that. Okay. We also completed something like word to vec. We completed average word to vec. In word to vec, we discussed both skipgram and CBOW. LSTM also completed. Okay. Now today we'll start. What are the pending topics that we really need to complete? I'm just going to write down. Okay. So today we are going to finish up bidirectional LSTM RNN with practicals. Okay. So here we are also going to do practicals. Okay. Then probably the next topic that we are going to see after this is something called as encoder decoder. This will basically happen in the next class. Okay. We'll also do a project with respect to language translation. Then we'll go with transformers, BERT, and GPT. We'll understand this all architecture, in-depth architecture. And then finally, we'll do some practical applications on all these things. Okay. And if you are probably good with all these things, I think there'll not be anyone who can stop you from getting jobs. Okay. So we will be completing all these things as we go ahead. Okay. Perfect. So shall I start the session, everyone, with respect to bidirectional LSTM RNN? Manoj Samal says, with the help of you, Krish, I got data scientist in Tata Elxsi. Congratulations. Yeah. John, when best platform to practice MySQL? You don't require any platform. You basically need to practice through, say in iNeuron also there is a MySQL course. Very nice MySQL course. Everything is available. Okay. So shall we go ahead and start, guys? Yeah, so this will probably take 2 weeks time to complete everything. So we are going to take 2 week timeline with respect to making you understand everything. Okay, so 2 weeks timeline. Yeah. Yeah, accessibility you'll also be able to see from mobile handset and download the materials, everything you can basically do. So let's start, guys. Yeah, whoever has bought in the earlier also will get lifetime. So you can just go ahead and ask it. Okay. So hit like, guys. Let's start. And we will be starting with bidirectional LSTM RNN. Okay. So let's go ahead. Okay. Bidirectional LSTM RNN. And I hope everybody knows about LSTM RNN. We have already done the practical implementation. Okay. So to begin with, first of all, what I will do is that with respect to bidirectional LSTM RNN, first we will try to create a simple RNN. Okay. So we will try to create a very simple RNN first of all. So let's go ahead. Okay. How does the RNN look like? You will be seeing this kind of boxes. Okay. So everybody remembers how the RNN architecture looks like. Yeah. It looks something like this, right? With respect to time stamps, we will be giving our inputs, right? Right. So over here, let's say I'm doing a task predicting the next word. Okay. Predicting the next word. So the task is very simple. Over here, I have a sentence which says like Krish likes to eat dash in Bangalore. Okay. Something like this. Some statements are there. Okay. And probably whatever output that I have over here, this is basically my training data set. Whatever output I'll be having, that will be my output value. Okay. Now let's consider in this specific way. So I really want to train this entire sentences with respect to this, and I want to do the task of predicting the next word. Okay. Now, first and foremost, like with respect to any architecture of RNN, you know that if I have this kind of values, then I will probably have words like x11, x12. Okay. So let's say I have some words over here. Okay. So let's say I have some words like x11, x12, x13, x14, x15. Like this, I have a lot of words. Okay. x16. Now, let's say that I'm giving my first word over here. So this will be my x1 word. Okay. Now this x11 word, what it will do at time is equal to 1. We are going to send this particular word, right? And as you know, let's say this LSTM over here, RNN will take x0 initially, and this will be the x1, which we will basically supply. And then from here, we will be forward this over here, but in the next time is equal to 2, we will be having x12, right? X12 is my word that is going to come. Again, I'm going to have over here y11, y12, and over here I'll be having y13, right? And then probably this is my input that will go over here. Then let's say at t is equal to 3. What will happen at t is equal to 3? We will be sending our next input. So here I will basically be having x13 at t is equal to 3. And here we are just going to supply x14 at t is equal to 4, right? Everybody remembers this simple architecture with respect to timestamp? Yeah. With respect to timestamp, everybody remembers this? Yeah. Very simple, right? So what is this? This is nothing but a normal RNN, right? So here I will be having my neurons, right? Here neurons will be there. Here neurons will be there. Here neurons will be there. Okay. Everybody clear with this simple diagram? What I've actually done? Yeah. And whatever x12, x13, x14, this we are giving in the form of embedding layers. What is embedding layer? If you remember embedding layer makes sure that whatever text we are giving it converts this into vectors. In short, this is a many-to-many RNN. Okay, you can also say this as many-to-many RNN. Yeah, perfect. Many-to-many RNN. And here, whatever values you're giving, x12, x1, x11, x12, x13, x14, whatever words you're giving in the form of vectors. Okay. Now, understand what is the difference between bidirectional and normal LSTM RNN. Okay, that is what we are going to discuss. Now, let's say the word that I really want to predict is this specific word. Okay. Now, tell me over here in this kind of sentences, right? Krish likes to eat something. It can be apple, chocolate, it can be anything, right? It can be any food items over here, right? Now, in order to determine this, obviously, you know, y13 when we are trying to find out the output, you know that y13 will have the information of x13, right? It will have this specific information. It will make sure that it will also have information of x12 and it will also have the information of x11. Do you agree with this, everyone? Yes? Do you agree with me that it will have the information of all these particular words? Why? Because with respect to y13, you know that from this, at every timestamp, these words are getting added. So tell me one thing, whether they will be knowing this specific information or not, whether y13 will know the output, will have some context with respect to these three words. It will definitely have. Y13 will have the context of all these previous words that are there. But always remember, if I really want to do this kind of predictions, this prediction needs to also be dependent on the forward words, right? All the operations are same, like how RNN over here, we will be assigning some different weights. Here we'll be assigning some different weights. Let's say over here, I will be assigning W1, 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 right? Over here, this will be my O1 output. This will be my O2 output. This will be my O3 output. Here also, I will be having different weights like the W dash, W dash, W dash, right? Everything will be almost same, like how we discussed in the RNN. But and understand that for this specific word, it will obviously have the context of the previous word like x13, x12, x11. But this will not have the context of the forward words, right? It will not have the context of the forward words. If it has the context of the forward words, then probably this blank that you see, right? It will be filled with what is famous in Bangalore. Like I like to see that Krish likes to eat shawarma in Bangalore, because in Bangalore probably you may get a good shawarma, something like that, right? So based on this forward words, right, these words can also change, because instead of Bangalore, if I probably say some other city in UP or Lucknow, right? In Lucknow, what is so best? Tunde kebab. Have you heard of tunde kebab? Tunde kebab, right? This is the most amazing food item over there, right? So this specific word may change based on this further words that is going to come in the sentence. Okay. So what I want is that whenever we are doing this prediction, this should also have the further words context. I hope everybody is able to understand, guys. Give me a quick yes if you are able to understand, or hit like, do something, tell something whether you're able to understand this thing or not. Yeah, everybody is able to understand this thing. What I'm actually trying to say, the blank space, whatever word we are trying to predict, should have the context of the forward words. But in this particular case, I don't have the context. This will not, y13 will not know that what is x14, because here we are basically using a simple RNN. I'm just considering this as a simple RNN. Let's say I don't know what will be the further words. Obviously over here x14, I'll definitely not know what is the context of this. With respect to y13, it will not have any idea. Now, what else we can do is that we can make sure that we can provide the context to y13 about the further words, and how we can basically do that. Now, what I'll do is that I will introduce you to something called as bidirectional LSTM RNN. Okay, let me just make my screen size a little bit smaller so that you'll be able to see this. Okay, now here I'm just made my screen smaller. Now here, what I will do is that in order to make the context reach y13, okay, here I will create a same neural network. Let's say in this color, I'll create the same neural network like this. One more neural network, I'll connect it to something like this. One more neural network, I'll connect it to like this. One more neural network, I'll connect it over here. Okay. And why I'm connecting this? Because I want all this information to go in the reverse manner and make sure that y13 also will come to know about this, right? So what I'll do now, here this x14 will get connected to this, okay? Will get connected to this. Whatever output that you're going to give over here, this will get connected to this specific output, okay? Similarly, what will happen is that this layer to this layer will get connected, right? Then whatever output again is coming from here, it will get connected to this, to this. Similarly, from here to here, right? Here to here, this will get connected. Whatever output you are going to come up with this will get connected to this. And from here to here, it will go over here. And whatever output is coming over here, it will get connected to this. Is this making sense, everyone? So this is the idea about bidirectional neural network. Now see, by this connection, what is basically happening? We are sending this text from the reverse order also through some other RNN. So as we go with y13, now it will have the context of x13, x12, x11. And it will also make sure that it will have the context of x14. Because why? Because x14 is basically getting passed over here. And I will also add to some lines over here with respect to this also. So this will also go as an input. This will also go as an input. And this will also go as an input. Does this make sense, everyone? Are you able to understand this part or not, everyone? Yes or no? I hope you are able to understand why this thing is basically done now. Because now this neural networks that is getting trained, this is also an LSTM RNN, right? This is also an LSTM RNN, and we say this as both, if it is combined, it is a bidirectional LSTM RNN. Okay. So along with the input data that you basically have, it is also going to make sure that you will be passing, let's say from the reverse order, all these words to this neural network. So when we have y13, now it will have the context information of the further words, and it will also have the context information of the previous words. And now if we train this model in proper way, you will be able to probably predict the accurate result over here. Simple. So in short, if I say, I can say, if I have this, see, now I'll draw it in a very shorter manner, okay? Bidirectional LSTM RNN looks something like this. Okay, the size will be almost same. Okay, so here we are passing these words. This will also go over here. Okay, with respect to this specific word. Then the second word will get passed over here. This will also go over here. Third word will get passed over here. This will also go over here. Each and every one will be having its output. This output will be combined to this. This output will be combined to this. This output will be combined to this, right? And this all neural network will be combined to each other. That's it. How do we decide? That can be a hyperparameter tuning, right? And these are all my neurons. That's it. So simple it is now. You can use LSTM RNN, you can use RNN, anyone, right? But at the end of the day, what you're doing is that in the forward direction also you are passing all the words, in the backward direction also you are passing all the words. So with respect to every output here, it is getting joined, right? With respect to every output, here you'll be able to see that it will also have the context of the previous word and context of the forward words. And that how cool this bidirectional LSTM RNN is. And over here in the output layer, you'll be seeing that we can either use sigmoid or softmax based on the classification problem, right? If it is a classification problem, you can use either sigmoid or softmax. Here also you can use the same thing. Here also you can use, in case of regression, you can use something else, right? So this is altogether a bidirectional LSTM RNN. How many of you were able to understand this? Because these all are important, guys. See, if I'm able to make you understand this, then you'll also be able to understand encoder decoder, right? Because the idea of encoder decoder is somewhat related to this. You should know how things are basically connected to each other. Yeah. So everybody clear with respect to understanding this? Yes. Shall we do a practical application? Yeah. Everyone, shall we do a practical application quickly? Shall we do a practical application, guys? Yes. Tell me yes or no. So I will just open. Yeah, everything will make sense now. I'll show you the example of how to pass a sentence and all everything. Okay. So there is something called as fake news dataset Kaggle. Now everything will make sense since that is the reason why I'm doing this practical for you all. We'll take up this data set and we'll try to implement this. What is the data? So data, you can download it over here. So here you have your train data. So download this train data if you want. Okay. So this is your train data that is basically coming. Open Google Colab, everyone. Just go and search for this fake news Kaggle dataset. Okay. Fake news Kaggle dataset. And download it. I'll just go and open my new file, and also make sure that I'll share you this link so that you can also see the track of everything that I do. Okay. Okay. So let this, and here I'll just change the runtime to GPU so that I can use the GPU, and I'll connect this. Okay. And now I will just open this. So whatever things you are doing, please make sure that you download the dataset and upload the dataset over here so that you can basically work. Okay. So here now you can see, guys, here I have extracted my dataset folder. Now all I'll do is that I will try to upload this dataset over here. Okay. So this is 96 KB. I know how much time it will take, but let's see. It'll get uploaded. Yeah. So now this data set will get uploaded over here and we will start the work with respect to this specific data set. And if you want this, I will share this link with you so that you can see the track of it. Okay. Copy link, and I will give you in the link in the chat. Okay. So I think everybody has got the link. Just open that and I will start. Now here you can see I have the train data set. Now let's start the coding part. As usual, what problem statement we are trying to solve? We are trying to solve a fake news classifier data set, right? So we are solving a fake news classifier using bidirectional LSTM, right? At the end of the day, the information that you will be passing will be in the form of vectors. Okay. So data set, I've basically taken it from here. So I'm also going to give you the link. Data set. Okay. And as usual, we'll start with import pandas as pd, df pd.read underscore csv, and this will basically be my train.csv. Okay. So I'm getting an error. Not a problem. Let's see why we are getting an error. On error tokenizing end of string at line 2180. Let's see. Are we getting some problem with respect to this? So everybody, I hope just open this data set and let's see. I'm just opening this data set. Let's see how it looks like. Okay, let's do one thing. Whenever we get this kind of errors, there is a parameter which is called as parses. Let's see how to solve this. Okay. Whenever you get this kind of things, guys, please make sure that you watch this, how to fix this issue. So here you can see why you're getting this issue. You can use this engine. engine is equal to Python. Okay, let's see whether this will work or not. Unexpected end of data. Okay, we are getting some errors. We change this to C once. End of string starting at. So guys, anybody who's able to read this data set? I'll use one more error. Wait. Let's see, something will be able to get it. To use coding, encoding. Yeah, here you go. Mhm. We're getting this error from this fake news classifier dataset. End of starting at 547. Let's see. Ignore errors. Reading dataset from pandas. We given error underscore bad lines is equal to false. Guys, are you able to read this dataset? Anyone? Perfect. Finally, we can see this df.head. I was able to get something. Okay, so this is how the dataset looks like. Okay. Uh, there was one error somewhere. So I've just used error underscore bad underscore line. Just remove that wherever we are trying to get an error. Okay. Just to make my work a little bit easier. Probably I'll just click this. Now here you can see this entire dataset. Oh my God, this looks way bad. So you can see this entire data set over here. Let me just execute it again. So this is how your data set looks like. Everybody is able to see the data set. Now what we are going to do, let's take this title column and let's try to do this sentiment analysis prediction with the help of bidirectional LSTM. Okay. Now, first of all, we'll go and see whether there is any null values. So here you can see that we have some null values like 195, 674. Now with respect to label, we don't have some values of features are basically null. But if you probably just write df.shape, I think we will be able to get 7,000 records. So there are 7,000 records. I probably feel like if you try to remove the null values also, it won't impact that much. So what I'm actually going to do, I'm just going to say drop NA, and with respect to text, right, you cannot do much, so you probably have to drop it. Okay, so df.drop na, I have specifically done the drop statement, and then if I probably go and see the head, here you'll be able to see the head. Okay, now out of this I don't require id column, or this label column is basically my output feature, and I'll take this as my independent feature. So let's go ahead and write get the independent features. Okay, so here let me write x is equal to df.drop a label is my feature, and this is my output feature, and I'll write x is equal to 1. Okay, So here it is. Then I can also write df of label, right? So this becomes my dependent feature, right? So here is my x and here is my y. Okay. Now let's see whether data set is imbalanced or not. Check whether data set is balanced or not. Okay. So here I can basically write y dot value underscore counts, and here you can see that whatever values that I can basically see. Okay. So here it is. Here you can see that, okay, it is not completely balanced because we have good number of data with respect to positive and negative values, right? So what we're going to do now is that let's go ahead and import TensorFlow. And before that, let's see whether we have TensorFlow or not. TensorFlow as TF. And before that also, because still there are so many things that we really need to do, but I really want to import all the libraries in TensorFlow. Okay. So if I probably cite tf dot underscore version, by default now Google Colab has this. So here you'll be able to see 2.2.2.8.2, right? Now I'm going to import some important libraries of TensorFlow. So here I'll say TensorFlow dot keras dot layers. I'm going to import embedding. I'm going to import embedding from TensorFlow dot keras dot preprocessing from TensorFlow dot keras dot preprocessing dot sequence. I'm going to import padding sequence. This is just for the pad sequence, which we have also discussed in our previous tutorials, right? And then from TensorFlow dot keras dot models, import sequential. And then from TensorFlow dot keras dot preprocessing dot text, import one hot, because before applying to one before basically applying to embedding, or before giving the data to embedding layer, we also need to do one hot encoding. And then from TensorFlow dot keras dot layers, I'm going to import LSTM. LSTM is definitely required over here. LSTM. Okay. And then from TensorFlow dot keras dot layers, I'm also going to import dense for creating the neurons. And from TensorFlow dot keras dot layers, import bidirectional. Bidirectional is required because we are creating bidirectional LSTM. So all these things we are going to basically use it. So all these libraries we are going to use it over here. And what we are also going to do over here is that first of all, we'll fix some vocabulary size. Okay, so it is always a good habit that we try to fix a good vocabulary size so that we can play with it. So let's go ahead and write vocabulary size, right? So here, this is my vocabulary size. Let's say I'm taking 5,000 words in my dictionary. Okay, 5,000 words in my dictionary, so that I can actually create my indexes in short, right? So let me first of all I need to do some processing before I send. Okay, so I will probably write messages dot x dot copy. So this x is my entire data set, right? So I'm just making a copy of this over here and storing it in messages. So if you probably see messages, these are my entire data frame with respect to all the input features. Okay, so here is my input feature. Now the first thing that I'm actually going to do over here is that this ID column is also not required. What we'll do, we have to play with this title column, or you can play with text column, but here I'm going to basically play with title column. Okay, now in order to play with title column, the first thing that I'm going to do is that just import NLTK. Let's see whether NLTK is installed or not. I don't know whether it is installed or not. Okay, it is perfectly installed. I think by default it is going to give this. And here I'm also going to install RE, regular expression. And from NLTK dot corpus, I'm just going to import stop words also. Stop words. The reason I'll be using stop words to remove unnecessary word over there. And here I can basically write NLTK dot download. I will try to download all the stop words also, so that I can play with it. NLTK. NLTK. Okay. So this will get downloaded. So here you have the complete downloading process. Now I'm just going to copy some important code over here. And here you can see that what exactly I'm doing. I'm using Porter stemmer. This Porter stemmer is for the stemming purpose. And why I'm using stemming, because this is a kind of problem statement where you focus more on implementing you know implementing sentiment analysis. So I will probably be using this. So here you can have see that what I'm doing. I've used Porter stemmer for I in range of 0 comma length of messages. I am first of all removing all the special characters other than small a to z and capital A to z on every title that I have. I am lowering it, splitting it, and then over here I'm applying it to the stop word and then stemming it. And finally, I'll be able to get my entire data in corpus. So here, if I execute it, what is the error with respect to key? So let's see this. What is the error? Messages dot head. If I probably see the 10. Okay, I have removed some of the data, right? So let me do one thing. Here, I'm just going to write messages dot. I'm just going to make one more code cell because I have removed the nan values, right? So here what I'm actually going to do is that I'm just going to say messages dot reset underscore index. Okay. Oh, no, it is not a syntax issue. We are just not getting this key value. Okay. So if I probably reset index and say in place underscore true, now you'll not find any gap. Okay. In place is equal to true. So here I'm just going to execute it. Now I think it will start working. No need to print I over here. Otherwise it will take, let me just print I so that you'll be able to understand how much time it is taking. So here everything is happening, and slowly for every column you'll be able to see this process happening entirely for all the title message. Okay. So we'll wait for some time till this entire thing happens, and here you can see that it is getting updated 2075. Yes, perfectly. It got executed. Now if I probably go and see my corpus, here are all the corpus after applying stemming and all. Okay. Can we apply multi-thread or process? Yes, you can also apply that, but you really need to follow a different approach. Now this is my corpus. This becomes my input feature. I have my output feature, as you already know. Okay. So this is my entire corpus. Okay. Now the next thing that I'm going to do with this specific corpus is that, I am just going to apply my technique of after seeing this corpus, I just need to apply my embedding. And before I'm applying the embedding also, right, you have to also make sure that you apply one hot encodings on that before applying embedding, right? So for doing that, what I'm actually going to do is that, obviously you know how to do it for one hot encoding. One hot encoding is basically done from one hot, the library that you have imported. Now let us go ahead and try to basically use that one hot on this specific corpus. Okay. So let's quickly go ahead and write our code. So here I'm basically going to say one hot underscore representation. And remember, this one hot representation will be based on 500 vocabulary size. Okay. So here I'm just going to write one underscore hot. And here I will just give my words and my vocabulary size. and I have to provide these words, right? So I'll write for words in corpus. So I'm just going to go ahead with each and every words in corpus, and probably we can print the one hot representation. This one hot representation, it will give us all the indexes. Okay, so here you'll be able to see all the indexes with respect to every sentences. So this is my first sentence. These are the indexes that I am getting. This is my second sentence. This is my third sentence. So all this print statement you'll be able to see. If I probably don't print this like this, then you'll be able to see in the longer manners. Now here you can see for every sentences you have, this is what you get. This is the based on the vocabulary size, this is the indexes that you're actually getting it. Okay, so here is what you are able to see the entire data with respect to the same corpus data. Now after converting this into indexes, the next step that we really want to specifically focus on is how we can pass this to an embedding layer and then bidirectional LSTM layer to basically do the prediction. Okay, so that will be our next step. Because this is the step that we usually follow with respect to, first we do one hot encoding, then now all we do is that we try to apply an embedding representation, because at the end of the day I have to basically convert these words into vectors. So here first of all I will take the maximum sentence length. Probably over here I have already verified it. The maximum sentence length that can occur is 20. So I'm going to basically put up 20. And then now I'm going to apply the embedding layer. Now before applying the embedding layer, I need to also use the padding sequence, which you probably saw, right? The padding sequence needs to be applied just to make sure that all the sentences are of this particular sentence length, that is 20. So for that I will use pad underscore sequences, which I had already imported on the top. Okay, so just a second. Okay, here I'll write sentence underscore length 20, and then here I'll write pad underscore sequences. Okay, and here I need to provide all my one hot representation. So here you have one hot representation, comma. The next thing is that whether you want what kind of padding, whether you want pre-padding or post-padding. So in this case, I will say pre-padding. You can also use post-padding. I don't think so it will make much difference. The max length that I'm going to basically do is my sentence length. Okay, and this entire thing I'm going to basically show it in my embedded docs in a new variable. Okay, and here is what I'm going to do. I'm just going to show my embedded underscore docs. Now here you'll be able to see this is how my padding will basically occur, and this is my entire one hot representation. Now let's go ahead and create the model. Now to create the model, I have used a very simple process. Okay, so here it is, what it is creating a model. First of all, with respect to embedding, right? Now here I have got this all documents after pre-padding, right? Now this entire indexes will get converted into vectors. Vectors of the size of 40. Why I have taken 40? Because sentence length was 20. I thought 40 would make more sense and we will be able to get good accuracy over here. Okay, so here I have made it as 40. Then we used sequential layer. Then here I've used embedding layer with the same vocabulary size, embedding vector features from where I'm getting embedding vector features over here. So embedding vector features is nothing but 40. Input length, sentence length should be the same, like 20 here, which I have actually initialized. And then I've used an LSTM layer over here. And then here you can see dense layer. Okay, but still you may be thinking, Krish, where is bidirectional then? Guys, like this, how we did it for LSTM, right? For bidirectional, all we have to do is that just add here bidirectional on top of it. So once you add like this bidirectional and probably close this brackets, then this will basically become a bidirectional LSTM, right? On top of the LSTM, I've just noted down this as bidirectional. That basically means 100 neurons forward, 100 neurons backward, with respect to that LSTM architecture that we have in mind. Then since this is a binary classifier, I've used the activation function as sigmoid. Then the loss function, I've used binary cross entropy, optimizer Adam, matrix accuracy. And here you can basically see the model summary. So I'll just go and execute this. After executing it, you'll be able to see the output. Okay. Yeah. So this is how many number of parameters we have created with respect to weights and bias. I've used embedding layer, one bidirectional LSTM layer, and dense layer, and finally I have this dense layer as my output. Okay, guys, is it making sense, everyone? Max sentence length is 20, then we can have 100 LSTM. Now here I've just given a number as 100. You can try with multiple different numbers also. Okay. So till here, I think we have done it in a better way. Now all I'll do is that let's do one thing. Train test split also I need to do. First of all, I'll convert this entire embedded docs that I basically have right over here into an array so that I can supply it. Now I will do a train test split. So train test split. Okay. For train test split, obviously you know how to do it. Train test split. It's very simple. We'll just use this train test split of sklearn and just execute it with x final, y final. I'll get my x train, y test, and this one. Now finally, I will go ahead and do my model training. Okay. And then I will write model dot fit. Okay. On my x train, comma, y train, comma. I can also give my validation data. My validation underscore data is equal to that is my x test, comma, y test, right? These are my validation data. Number of epochs that I'm just going to run for just checking it out is 10. And my bash size, I'm just going to keep it as 32. I think in that much RAM I have. Okay. So let's go ahead and execute it. Hope so. Everything works fine. Epoch 1 has started. I don't know how much time it is going to take, but let's see. It is going to take definitely some amount of time because I've also taken 10 epochs. Bash size is 32. Here it is. So we have started the training over here. Perfectly. All right. Training is going on well. The validation loss, validation accuracy, this loss is also getting decreased, So here you can see good amount of information that we are able to see, right? Yeah. So just with 10 epochs, I'm able to get training accuracy this much, validation accuracy this much. Okay, which is good. You can still train it for any number of epochs that you basically want. Now what I will do is that I will probably use the confusion matrix and do the prediction. So here I'm just going to write ypred is equal to model dot predict on my x test data. Okay, and probably this will be my ypred. Let's see. So if I probably see ypred, I think it will get in form of probability. So what you can do is that you can basically use another classes, which is like underscore classes, to get what is the exact output. Okay, predict underscore classes is not there. Huh? Let's see. Model dot predict. Okay, predict. I think predict underscore classes has been removed. Now here all I can say is that greater than or equal to 0.5. Okay. I'll just execute this. Then you will be getting true or false. And probably wherever it is true, greater than or equal to this. Wherever it is true, we will try to, or let me just write with numpy. Okay. Import numpy as np, and here I'll say np dot where this is this. I'm going to replace it 1, otherwise 0. So here we can use np dot numpy. Yeah, perfect. So this I will save it in my y underscore pred. Okay, I've just kept the threshold as 0.5. Okay, then from sklearn dot metrics import confusion metrics. Okay, and then I can probably use this confusion underscore metrics with y test comma y pred. Should be metrics. Okay, so yes, this much accuracy at least we are able to get with respect to the right prediction. We can also use accuracy score. Okay, and here you'll also be able to see the accuracy score. Okay, Now probably you can print this accuracy underscore score with y underscore test comma y underscore print. So this is how much I am able to get, somewhere around 90% accuracy with respect to the training data set. So this was how we basically implemented a bi-directional LSTM RNN. You can do with other examples also. At the end of the day, you will be creating a bi-directional LSTM RNN to do proper predictions. Okay. Model will not have any data leakage problem because I have made sure that the train test split is done in better way. Okay. Guys, so how was the session, everyone? Was it worth? Were you able to understand? Were you able to understand all these things, whatever was discussed in today's class? Yeah, everyone. So this was all about LSTM RNN, bidirectional LSTM RNN. We covered both theory part. So here you could see some theory, amazing theory over here. In short, what we did is that we tried to use both RNN from the forward layer and from the backward layer, right? Over here, two sets, and how it knows that it has this information over here, right? So this kind of neuron has only got created. Now we are actually trying to find out the output after taking the entire sentences. But if we also try to do it, I think it'll make sense, right? So in short, this is how things work. And probably in the future, we are also going to do language translation. We are going to do encoder, decoder, and then we are going to understand all these things, right? So I hope everybody got the materials. I hope everybody was able to try it out and probably check it out. Now, the next session we will probably have on Friday. Okay, on Friday we will start with encoders, decoders. So I hope you like this. One quick announcement, guys. Just go ahead and visit iNeuron. Okay, we have launched this Tech Neuron, one neuron platform. This will be available for lifetime at 10,000 rupees. Here you have 200 plus courses, and if you feel 10,000 is also costly, you can use my code, that is Krish20. Okay, so if you're probably buying this with the help of my code Krish20, you will be able to get 20% off. Okay, so but this has amazing things because all the courses we have included over here, even the live courses that are going to come in the future will be included over here, so you'll be able to attend any live courses over here also. Okay, so and this is lifetime is only for this, more 4 days are left till Sunday, so please utilize this opportunity. All the information regarding this is available in the description of this particular video. Yeah, if you also don't want to buy it, you tell it to your friends, whoever require it, because not everybody cannot afford a very high cost fees, and we are always working towards affordability, right? So yes, support us to help us in this noble cause. And I think this session was good. All the links, everything will be provided with respect to this specific session. And yeah, advanced neuron, already I've given the course link niche, down in the community session or community session link. So over there only we are going to update all these things along with the materials. Okay, so thank you guys. This was it. Anything you have to talk, please do let me know. If you have any type of queries, you can let me know. Any concerns, you can let me know. And also make sure that you subscribe Krish Naik Hindi channel, please. I'm also going to start Krish Naik Hindi channel, some interview playlist that I'm going to start. I'm going to discuss every day 2 to 3 couple of questions with respect to interviews. So please make sure that you join that or subscribe that channel. Okay. Yeah. And anything that you have other than that, I can definitely help you out if you have any question. Okay. When are you starting projects? Which projects? Project NLP projects end to end. that will start once we complete all these things, right? Okay. I'll also give you an idea with respect to real world projects, how we can basically do it. And guys, if you really want to support me, please make sure that provide some donations, join membership, support me in somehow, it becomes difficult, to devote much time. So I really want some support, and obviously can't earn much money from YouTube also, you know specifically tech channel like ours, teaching. None of the people are interested in teaching. Today also hardly 87 to 100 people have joined. So this is really bad, can't help, but definitely make sure that uh, try to support the channel by joining membership, uh, making sure that I provide you the best quality thing. So that is what we are trying to do. Okay, that is only the thing that I can request. Other than that, nothing as such. But I will keep on uploading videos. Please make sure that you subscribe Krish Naik Hindi channel also, and there I'm going to basically start post this one interview preparation batch very soon. From I think from Friday, that is going to come up. Okay, Krish, make a video on college toppers someday. Sure, I will do that. Ankit Solo says thank you. Because you're not consistent. Last class there were 3000 viewers. No, last class every time there are 100 viewers only. I took 3 months live session classes and people are not at all interested. They told they'll come at 8 p.m, but still people are not there. Multiprocessing for a loop, can you use dask libraries there? Try to use that, it will do the parallel processing for loops also. Okay. TK Yadav says, Namaskar, sir, with your community and God blessing, I got offer from Cognizant 18.70 lakhs per annum. Please suggest me how much is optimized CTC for 5 years from Deloitte. I think that is fine. For 5 years, 18.70 is amazing. Right? I think you should go ahead with it. It is more than 3 lakhs. 3 times, So that is absolutely good. Congratulations, DK Yadav. This is amazing. Perfect. This is quite amazing, guys. I like people. See, people see trust sometime. See, always understand. You all need to understand that whenever these things that what we are going to do, right? This tech neuron, this entire technical things has a lot of things over here. You have a lot of opportunities with respect to jobs, with respect to multiple things as such, right? So this is super fun. You should just devote time. There's so many openings, but people are after things where there are very less number of openings and a lot of competitions. Yeah. Thank you, sir. This is my second transition from data engineer. Awesome. Awesome. Okay. Any more question, guys, that you have? Please do let me know. I'm working as a data analyst for Blue Dart, and your videos were really helpful. Amazing. Congratulations, guys. Congratulations. Thank you. Sometimes this success stories, right? This looks amazingly well. I feel really happy. Uh, this gives us motivation. Guys, is this time fine? 8 p.m. to 9 p.m., I guess, with respect to think. Please correct the pin message. Okay, it's fine. Not a problem. And make sure that you join the Telegram channel. I know code, but in front of the interview, I'm completely blank. So you have to talk. You have to talk. Right. Unless until you don't talk, it'll not work out. Okay. Donation was for the love I got from your streams. Thank you, Nihal. Thank you. Thank you, DK. Hey guys, sometimes right, donations is required. Like Do you know how many videos I've uploaded in my channel? Around 1500. Just imagine. I still think that how is that possible really in just 2.5 years? It's very difficult. Really, really very difficult. I'm getting a problem on solving end-to-end advanced NLP. Don't worry, I will take couple of problem statement and projects on that. Sir, please review CDAX DBDA. It's a government post-graduation course. I'm not sure about this. Okay. Bala Murali says the Telegram link is not working. No, no, it should work. Telegram link should work. Try to, yeah, I can see that it is working. It's working fine. I watched your old videos every day. It's really awesome. Thank you. Thank you. Thank you. Thank you, guys. I have an interview in the jungle company for applied scientist role. Can give you some tips. It's based on an NLP playlist. Make sure that your basics are strong. That is super important. Your basics are strong. You don't have to go and talk about BERT architecture and all, but understand what NLP things you can basically do. That is very important. Okay. Mm. That is super important. So unless and until you don't do that, you will not be able to. You have to be confident. You should know how to talk. I've seen people who don't have much knowledge in NLP, then also they crack interview jobs because their basics are strong, right? Okay. I wonder why the UPSC video is still there in the playlist. That is how I started my YouTube career in short. I uploaded a video at that point of time just to see that how good I am. Is there a separate NLP master course in iNeuron? Yes, in the FSDS only we have included all everything. So guys, the FSDS batch is also getting launched from September 17th. FSDS batch, so you can also join that if you want. Job guaranteed program. Everything is there. But at the end of the day, Telegram link see in the pinned comment. Can we have a session for implementing or something like Jarvis? Sure, I can do that. See, something that is already there, why you want to again implement it? What we choose between strong basics or all things known. You see, there is a point till that specific point you need to know, right? If you don't say some advanced things also, no, it is fine. But basics, if you don't say no, that will hurt the interviewer. Just qualified as a data scientist but struggling to secure a job. Work on your resume, work on your projects, work on your talking skills. That's it. Big love foreign content. Thank you so much. Thank you for the amazing series. Send super chat and then ask. Probably he'll do it. Don't come for free stuff. No, no, it's okay. If uh, whatever is there, I will try to get. Should I give TensorFlow developer certificate exam? Is it worth it? If you feel it is worth it, just go ahead and write it. You know. Can you please list out some resources for data analyst opening? Just go and check iNeuron job portal. I think there are a lot of data analyst openings that are currently going on. Content on net about targeted sentiment analysis is very less. Sir, will you be taking niche area sometime? Yeah, sure. I'll do that. Okay. Now, right now, more complex projects is going to come when you understand BERTs and transformers, because we are going to do the end-to-end application with Hugging Face library. It'll be quite amazing. Krish, it says there is a problem in purchasing. It should not happen. Try to contact the support team. Yeah. I checked a pinned comment, but there is no Telegram link. No, Telegram link is there, no. HTTPS. Pinned comment in this chat. As fresher, where should I apply for data engineer position? There are many companies. First of all, don't apply for a full-time job and instead apply for internship. Internship will be available more when compared to full-time jobs. Okay. Is Power BI certification for Microsoft worth it? Yes, well, this kind of tools, I think it will be of some worth, because at the end of the day, if you say I'm having a Microsoft certification, of the product that own Microsoft has created, then it looks good. Sir, please create an interview series again. It helps a lot for beginners or 2 years experience. Sure, Rishabh. Okay. So yes, guys, this was it from my side. I hope you like this session. Keep on rocking, keep on learning. Please keep on supporting, and please make sure that you press the bell notification icon. Next session we will basically be having on Friday, where we'll discuss about encoders and decoders, and we'll also be doing a practical implementation. Okay. So yes, this was it from my side. I will see you all in the next session. Yeah, you can contact me through LinkedIn. You can join the Telegram link that I've given in the chat. Yeah, this was it from my side. Bye bye. Take care. Rock. Everybody rock. Bye. Good night, guys. Yep.